Hey guys, happy Friday. We're back here with another math video. Before we get started, don't forget to rate, review, subscribe. No, I'm just playing. I'm not a YouTuber yet. Alright guys, so wanted to go over a couple of these inverse problems that we actually were kind of starting to do some of these right before this whole coronavirus break kind of interrupted us. But I want to go over a couple of these inverse problems and using them with our double angle formula, our sum and difference formulas, etc. This is actually number 99 from the book, but you don't necessarily need your book to follow along with me. So let's run through this real quick. I have the sine of the inverse of cosine of 1/2 plus the inverse of sine of 3/5. Well, really what this is talking about, again, this concept of inverse, right before we left, seemed to give some of you guys trouble. Remember, inverse is really just saying like, hey, I have these side lengths, and is referring us back to an angle, right? So I have these side lengths and they're referring me back to an angle. So it might help to kind of draw a picture that represents each of these two scenarios. Inverse cosine of 1/2 means I have a reference triangle that looks like this. And I'm going to call this angle A. Inverse sine of 3/5 means I have a triangle that looks like this. I'm going to call this angle B. All right. Well, again, how did I get these triangles? The inverse cosine. So that means this side length is really the adjacent side and the hypotenuse side. And it's referring us back to this angle A. Inverse sine of 3/5, that means 3 is the opposite side, 5 is the hypotenuse, and it's referring us back to this angle of B. So the inverse of, or inverse cosine of 1/2 is just angle A. Now we actually do know this angle. It's, dramatic pause for effect, it's 60 degrees. Now, do I really need to know that 60 degrees? Not really. And in fact, in a couple of these examples, I'm going to say don't worry about trying to find the exact value. Just label it as angle A. We can actually go ahead, because it's going to come up in a second, and use the Pythagorean theorem to fill in the other side lengths of these triangles as well. But look how I'm going to rewrite this. I'm going to write sine. I'm just going to call this A plus B. Again, the answer to the inverse cosine problem or the inverse sine problem is these two angles, A plus B. Well, sine of A plus B, we have a formula to deal with that. Sine of A plus B is equal to sine of A cos B plus sine of B cos A. So I'm really just using this, again, expanding this using our sum difference formulas. Sine A cos B, sine B cos A. That's the exact formula, right? Well, now let's actually take the sine of A and the cos of B. Well, we're going to use these same reference triangles we were just talking about. The sine of A is opposite over hypotenuse. The cosine of B, adjacent over hypotenuse. Plus sine of B, opposite over hypotenuse. And the cosine of A, adjacent over hypotenuse. Simplifying this out, we have 4 radical 3 over 10 plus 3 over 10. Oh, I'm a little off the screen there. Let me move this on up. Now, to finish this problem off, we just add these together. Now, they're not like terms, so we're just going to simply write 4 radical 3 plus 3 all over 10. That is the answer to our problem. So take a second, maybe check this out, review it, and I'm going to actually jump back in my next video and show you guys how to do some of these inverse problems using our double angle formulas as well as our power reducing formulas.